Hello and good morning. On today, we will begin in this film the new chapter number 3, Atoms, the building blocks of matter. Now, in simple description, atoms like blocks are very near to each other in a certain way that they are vibrating in the four directions and hitting each other. Now, as we know in solid, this configuration will be very near to the actual. The solids atoms are very near to each other. The distance is very small. In liquids, the distance is little more. This is solid. This is liquid. And in gases, the distance is too much bigger. According to this simple understanding, the atoms are blocks, the major blocks of matter. Blocks of matter. Now, there are three basic rules and laws that describe all how matter behaves in chemical reactions, and simply they are named by law of conservation of mass. That's meaning mass is neither created nor destroyed. So if you have a mass, then if it is converting to another type of mass, that's meaning it might be recycled again. For example, H2O is consisting from H plus O. They are reacting, but they are not disappearing, they are not cracking, they are not created, they are not destroyed. Then we have the definite law of proportions. That's meaning if you want to have H2O, for sure if it is in Jordan or in North Pole, it will be always H2O, that it's consisting of 2H plus 1O, and there is the third law called law of multiple properties. The third law, it is about always we have whole number, meaning the O has one atom and H2 has two atoms. I cannot say that I will divide this one by 2 and this one by 2. This half is not whole number. This is a fraction or rational number. So you cannot use it in your calculations. So you will not find H1 or half. You will find usually H2O as a standard. Now, on other hand, the compounds like for example C2H6 should have atoms in whole number ratio. It is 2 to 6, 2 carbon to 6 hydrogen. this is whole number as a compound. Now, there is something called empirical formula that also it is a whole number. We name it by E dot F, empirical formula. And for this particular example, this would be C1H3. That's meaning I cannot have less than this value as a whole number, so it will stay there. Now, in many other situations, there will be so many calculations for the empirical formula, at which I have shown these calculations, about 6 or 7 possible questions that might come in SAT exam on empirical formula. Check the classroom for films about empirical formula, and there are 6 examples, and in SAT exam these six examples, always one of them is mentioned in the SAT as a question in the SAT exam. Now, another point in chapter 3 is important, that the atom itself can be subdivided into smaller matters. Actually, on the grades of 7, 8, we were learning that the atom has a center, it's charged positive, and electrons are around it, moving in circular way, and here we have protons and neutrons inside the nuclei. Now, if you try to cut and subdivide the atom, you will find that there are electrons, protons, and neutrons. But these 3 items, you cannot crack them more. They are the smallest things in the world. The structure of the atom is also important, and always in SAT exam there might be a question regarding the structure of cathode ray experiment. Now, I have explained this one in the class, but I will repeat it in fast mode. Usually you should have a battery, source of power, source of ampere, source of electrons. So small size will give a line and like an arrow to show that electrons are moving in this direction. Once electrons are reaching to this point, and it is called anode, and SAT exam sometimes is asking you what is this name, this point. So it has a positive sign, that's meaning the electrons are moving in this direction, and we call it cathode ray here, this one here. So the atoms, electrons are hitting each other, and this would be gas at low pressure. So this area is positive, this area should be negative, and again the electrons will move in this direction to the battery, and this what caused the ampere to move. Usually the gas is neon, Ne, the noble gas of 10 electrons. This point is called anode, and this point is called cathode. Usually this is the simplest way to show the cathode ray experiment. Thank you and bye bye.